Hi, my name is Samantha, and today we're going to be going over a binary tree vertical order traversal. This question is just another variation of a level order traversal. So if you do not know how to do that, I highly recommend visiting that LeetCode question, figuring it out. It'll just make this question a lot easier to conceptualize. But basically this question is saying that given a binary tree, return the collections of nodes that occur in each vertical split. So if we were to cut or make these vertical lines starting from left to right, which nodes would be in each split? So in example 1, all the way on the left side, if we were to make a split, we just have the 9. If we were to make a split here, we would have the 3 and the 15. A split here, just the 20, and a split here, just the 7. And then in example 2, if we were to look all the way to the left, we would have just the 4, then the 9, then the 3, 0, 1, the 8, and the 7. So before we start coding, I just want to say that the best way to think of this is as a grid type of question with the coordinates. And so at coordinate x equals 0, if we were to make a slice, we have the 3, 0, 1. And then if we were to cut at x equals -1, we have just this -9. And at the -2, we have the 4. And at the 1, the 8, and the 2, the 7. So we can almost think of these collections as on an axis of, like, they are going to go negative and some are going to go positive. The main thing is that our root is going to start at 0 because that's all we're given and that's all we ever know. So our root marks the x equals 0. And with all tree questions, we're going to say if not root, then return. And for this coordinate grid system that I'm talking about, we basically need to save the column or the slice and then every node's value that occurs in that slice. So for that, we're going to use an unordered map of integers where the key is the column or the split, and then the value is all the nodes that occur at that slice. And just like all level order traversals, we are going to use a queue. And in our case, we can't just store the tree node itself. We also need to keep track of something else, which is the column. So we're going to do a queue of pairs of integer tree node where the integer is, of course, the column that we're at. And the first thing that we're going to do is we're going to say q.push, and you can do make pair in C++. I like to do this, 0 root. And that means in our little queue, we're going to have 0 and 3, and that's what we want to record. So at another time in our queue, we want to have -1, 9, and -2, 4, and 1, 8, and so on. And so just like how we do all breadth first searches on a tree, we say while not queue empty. We're going to get the size of the queue, and now we're going to have another for loop while size minus. The reason that we have to get the size is because the size indicates the number of nodes that occur in the next level that we're on. We want to stop once we've gotten all the nodes in that level. Again, it's really important that you know how to do a level order traversal before getting into this question. And so we're going to say auto p equals q.top. In C++, you can do auto, and it knows that it's supposed to be a pair. So we're going to do q.front. Don't forget to pop your q. And now we're going to extract the current column that we are at is p.first because it's a pair, and tree node cur is equal to p.second. And here is where we need to put all of our information into this unordered map. Like just I was saying, we kind of have it in the queue, but that's just the single node and its column. We need to record every column and all the nodes that occur in that column. So we're going to say the map at column push back cur's value because we just want the integer value of that node. And now from here, just like your generic level order traversal, we're going to say if what's our cur's left exists, then we're going to say q.push. And what we need to push in the queue is obviously cur's left, but the column value is going to be 1 less than our current column, right? So we're just going to do column -1. And then we're going to say the same thing for the right side. If cur has a right, then we're going to push that with call +1 cur's right. And that's how you do that. And so by the end of this while loop, we will have something that looks like this. So we'll have a key value pair. And for example, 2, we'll have, maybe at index 0, we have the 3, 1. And then we'll have the 1 with an 8. And we'll have the -2 with the 4, and so on. I'm not going to write all of them out. So we know that we need to return a vector of ints. And so basically, we're just going to want to go through the map and just push back the value at that map, which is a vector, which is totally what this is looking for. The only issue is that we don't know the order of these key value pairs. We don't, just because we place them in the map does not mean anything. They exist randomly. And so the main trick to this question when using an unordered map is that we need to somehow record what is the leftmost column we have ever seen and what is the rightmost column we have ever seen. The reason that we do this is because it's better complexity. You want to always use an unordered map if possible over a map. And so I think that's like a positive thing about this question. There are many ways to do it, but I like to do it with an unordered map, and I'm going to show you right now that if we know that we have a -2 as our leftmost and a +2 as our rightmost, that's all we need to know, because the nature of a binary tree, you can't have a column of 2 without having a column of 1. The column of 1 had to be apparent to whatever exists on the right side. And so that's why we just have to know the bounds, and from there we can go through the map and extract it correctly. So we're gonna have some int min call, and the way that you do this is you always, if you're trying to find the max, you always originally set it to the min, and if you're trying to find the min, you always try to set it to the max. And then here where we are, inserting it into our map, we're just gonna say if call is less than the min column that we have ever seen, then we're just going to set min call equal to our current column. And the same thing, if call is greater than the max column we have ever seen, then max call is equal to column. And so now we know that in example number 2, our min call is -2 and our max call is 2. So now if we just start at -2 and go up to 2, it will correctly get the 4, the 9, the 301, the 8, and then the 7. So what we're going to do is we're going to say for int I equals min call, I less than or equal to max call, I plus plus, and dot push back map at that I. And then we can just return ands. And let's just make sure that we popped off. And let's see if cur left, cur right. Okay, this should be good. So the complexity of this problem is O of n, where n is the number of nodes in the tree. We do have to traverse and get to all of them to solve this. So let's go ahead and submit. And that is how you do this question. Thanks for watching.